Welcome to Kognito Key. Today, we are going to talk about a hidden, invisible force that's at work inside pretty much every electronic device you own. It's a force that's quietly wasting energy and creating heat you don't want. So, let's figure out what's going on.
It's a really good question, isn't it? You've probably felt it yourself. You know, that little bit of warmth coming off a power adapter or a motor. You might just think, oh, that's normal. But a huge part of that heat is actually a sign of energy just disappearing.
So what is this culprit? What's this phantom that's heating up our machines and making them less efficient? Well, the answer is a really fascinating electrical phenomenon.
Okay, let's get into it. Anytime you have a magnetic field that's changing, like the kind you find in a transformer or a motor, and you put a conductive material in it, that changing field creates a voltage, or an EMF, right there inside the material. It's one of the basic rules of physics.
Now, because that material is a conductor, the voltage it feels makes these tiny swirling currents start to flow, and we call them eddy currents. A great way to picture them is to think of eddies swirling in a river. They just go around in closed loops inside the metal, not really going anywhere useful. And here's the problem. These little currents aren't doing any work for us. They're just spinning around, and as they flow through the metal, they bump into its natural resistance, and that creates heat. Engineers have a name for this, I²R loss. It's just pure wasted energy, turning straight into heat.
So the big takeaway here is that these currents have real consequences. They waste energy, they create heat that can damage things, and at the end of the day, they make the whole machine less efficient. It's such a well-known problem, it even has other names, like iron loss or core loss.
All right, so now we've met these troublemakers, the eddy currents, and we've seen all the problems they cause. The next logical question is, how do we fight back? How do engineers get around this fundamental law of physics?
Well, they came up with an absolutely brilliant solution. It's so simple in concept, but it's incredibly effective. It's called lamination.
This shows the difference perfectly. On the left, you see a solid chunk of metal. It's like a giant open highway for those eddy currents to flow, and that creates a ton of heat. But now, look at the right. The laminated core is totally different. It's built from many thin sheets, and each one is electrically insulated from its neighbors. This basically chops that highway into tiny little country roads, making it almost impossible for big currents to get going.
Let's break it down real quick. First, they slice the core into these thin plates. Second, and this part is the secret sauce, they coat each layer with something like varnish. That insulation makes it so the current can't just jump across from one sheet to the next. And the result? The eddy currents are trapped in these tiny little sheets where they're super weak and generate almost no heat. It's genius.
And engineers didn't stop there. They also make these cores out of materials that are just naturally bad at conducting electricity, like silicon steel. When you combine that high resistivity material with lamination, you get a really powerful 1-2 punch against that energy loss.
But this is where the story gets really, really cool. What if this problem, this unwanted heat, could actually be turned into something useful? What if we could harness these eddy currents on purpose?
Say hello to induction heating. In this case, we deliberately create massive eddy currents in a piece of metal. That I²R loss that we were trying so hard to get rid of, well, now we use it to generate intense, focused heat. The auto industry uses this to perfectly harden the surface of heavy metal shafts, making them super durable without having to heat up the whole part. Eddy currents can also be used to stop things in their tracks. By creating them in a spinning metal disc, you create a kind of magnetic drag that works as a powerful, incredibly smooth, and totally frictionless brake. This tech is so reliable, it's used in everything from old electricity meters to the super advanced braking systems on high-speed trains.
And the applications get even more clever. In scientific instruments, eddy currents provide something called damping, which is just a fancy way of saying they stop the needle from bouncing all over, so you can get a nice, steady reading. They can also be used to find tiny, hidden cracks in metal parts without ever having to touch or damage them.
So let's bring this all together. Why does any of this really matter? I mean, it's not just about passing a physics exam. It's about understanding this constant push and pull in engineering between getting rid of waste and finding new, innovative tools. This really is the heart of it. What starts out as a flaw, a source of waste that you have to design around, can be completely flipped on its head. By truly understanding the science, we can turn that exact same flaw into a precise tool for heating, for braking, and for testing.
And that leaves us with a really fascinating thought. It kind of makes you wonder, doesn't it? What other things that we see as problems or limits in science are just waiting for some clever person to look at them in a new way and turn them into the next big thing?
If you enjoyed discovering how a scientific flaw can become a powerful tool, please subscribe to Kognito Key for more explainers that uncover the hidden science in our world. Do like and share this video, and as always, thank you so much for watching.